Hi guys, welcome back. We are talking about the evolution of niches and species distribution. I already started talking about this in class for most of you, so if you want to just fast forward to the parts that we haven't covered yet, feel free, or you can stay for the whole thing. Again, this is Module 17 and it will be on your exam tomorrow or Friday. Okay, so your learning objectives. After reading this module, you should be able to explain the difference between a fundamental and a realized niche, describe how environmental change can alter species distributions, and discuss how environmental change can cause species extinctions. So we talked about, or I think I've mentioned before, this idea of a range of tolerance. And this is basically the high all the way to the extremes, each extreme for how a species can, from where a species can survive, right? So in this range of tolerance that's presented here, on these two extremes, you'll notice that it just says that they're surviving. So it doesn't mean they're thriving. We want species to thrive. So these two extremes just means like, yes, they can tolerate these conditions, but it's really not ideal for them. And then as we get closer to this center range, this is where species can survive, grow, and reproduce. And looking at this image, really, we see that this shape can really vary based on the types of species that exist, right? So some will have a much larger range of tolerance, some will have a much more narrow range of tolerance. It really depends on the type of species we're talking about, and we'll look at how we identify which species those are. And really a range of tolerance is only going to look at abiotic conditions. So things like the temperature outside, the amount of water something needs, the types of soil it may grow in, pH of water or soil. Those are the kind of things that these abiotic conditions that will contribute to a range of tolerance. Now, within that range of tolerance, we have something called a fundamental niche. And the fundamental niche is still talking about those abiotic conditions, but it's the ones where the species is going to thrive. So specifically, the fundamental niche, if we go back to this and this image here, the fundamental niche is really going to be this big orange section right here. And I'm going to call this FN for fundamental niche. It's where species can survive, grow, and reproduce, or what I'm calling thrive. And that's this area right here. So the fundamental niche is where we'll see the most superior amounts of growth. However, you also have to take into account that you're not the only thing living in that area. So even if a species' conditions around it are perfect, it's the perfect amount of water, it's the perfect amount of soil, the perfect amount of everything, what it's not considering are maybe biotic factors, right? So other things like competitors, predators, diseases may also play a role in contributing to what a species' fundamental niche is. And I think this image actually does a really great job of describing that. So our fundamental niche here for this particular species of barnacle is this entire area here. Sorry, this is the fundamental niche. And it basically is saying here that this barnacle can thrive in a wetter condition or in a drier condition. And this is supposed to be representative of the intertidal zone. Now let's say we introduce predators, competitors, and diseases, and all of a sudden we have what we call a realized niche. So a realized niche is where the species will actually survive once those biotic factors are considered. So in this case, we introduce another barnacle species, and this particular barnacle species has the same fundamental niche as the other barnacles, but tends to have a preference towards these wetter conditions. So as a result, these tan barnacles, their realized niche ends up being way up here at the high tide area, which tends to be a little bit lower. So the realized niche is where the species actually ends up living once you take into consideration both abiotic and biotic conditions. And then this is the realized niche of these barnacles here. Okay. And then distribution is just in reference to where in the world those conditions can be present. So this barnacle can't only survive in this one area. They're probably distributed around the world where those same abiotic conditions can be found. Okay, so we talked about on that first page that a range of tolerance can vary, and we said that it kind of depends on the species how narrow or wide that range of tolerance is. And really what's going to depict that is the type of species and whether it's what we call a specialist or a generalist. So a generalist species is, I gave images here, so something like a raccoon or a rat. A generalist species is going to have a really broad fundamental niche because their range of tolerance is going to be really broad. They don't have specific climatic conditions that they prefer. They don't have a specific diet maybe that they prefer. They're able to just survive in a lot of different areas. And that's really, it's a good evolutionary trait because if anything were to ever change within one of these species ecosystems, there'd be a high chance of them being able to survive that change. So something like a raccoon, they can eat anything, they can live in hot, they can live in cold. They don't really have any specific ecosystem that they like prefer, right? And so if anything were to happen, like let's say there was a massive tornado that came through or something in the area where raccoons were living, they'd probably actually thrive after that. There'd be debris everywhere and they'd be able to sort of feed themselves still. Same with rats. So we would call those generalist species. And then over here, our specialist species, we've got things like a panda and a koala bear. They have these really narrow niches, these very narrow fundamental niches. And that means they have like a very specific diet. They prefer very specific climatic conditions. And the downside to being a specialist is that as soon as there's any change to your environment, you're very unlikely to survive it because you depend on these very, very specific conditions in order to be successful. So these are the types of things that might start to impact how wide or narrow your fundamental niche is. Okay, so however, there are sort of like three things where a species live, if that ecosystem does change, if it is experiencing change in some way, there's sort of three options here. You can adapt, you can migrate to an area where your new ecosystem is where your preferred climatic conditions exist, or you're going to die. So you either adapt, you move, or you die. And so what this image is just saying is that this particular tree species is shifting northward as warmer temperatures are starting to creep up. They're moving further north to get to those cooler temperatures that they prefer. And it's showing this adaptability of these trees to be able to migrate a little bit further north. But if you're not migrating, then you may not be successful. So how do we know about things like this? So we look at a fossil record. So a lot of what we know about how species have evolved or how they have adapted to changing conditions is by looking at a fossil record. And you're probably familiar with what fossils or fossil records are. They're sort of a look back in time at what species used to exist. Now, 99% of the species that have ever existed on this planet are no longer living. And we know that because we've found their fossils, and they're the fossils of things that are no longer in existence. So a lot of things have gone extinct on our planet. And we're able to look at this fossil record, and it gives us a really good indicator of the evolution of some of the species that we see today and how they've adapted to become something that does fit into the type of environment that we have. And generally speaking, the further down you go in soil, the older the fossil is. There's kind of one exception to this, and I like to talk about the La Brea tar pits just because they're so close to home. You don't necessarily have to know this for your AP exam or anything like that, but they are close to us, and they're pretty cool to go see. But right in the middle of downtown LA, there's a really large petroleum reserve under the ground, and it's called the Salt Lake Oil Field. And this petroleum reserve formed, 20 million years ago. There's a large section of marine phytoplankton that died and were deposited into this large ocean basin. And basically, years of heat and pressure have turned them into an oil. So the tar that you see boiling up to the top actually isn't tar. It's actually what we'd call asphalt. And asphalt is a form of crude oil. And asphalt is actually the lowest grade of crude oil. So it's just it's not very energy dense. When we say it's low grade, it means when you burn it, you don't receive the full amount of energy from it. So it's what's happened over time is over the last 50,000 years, all of this crude oil has made its way to the surface. And so within the last 50,000 years, we've seen a pretty drastic change in the types of animal species that exist on this planet. And this tar is really sticky. If you've ever been to the tar pits and you walk through the grass, you'll notice that it catches on the bottom of your shoes. All this tar has migrated to the surface, and all of these animals who have walked across it have gotten trapped and stuck, and this tar has made perfectly preserved fossils. And so the La Brea tar pits, not only are they like somewhat of a tourist attraction, but they're actually an active excavation site where they're pulling out tons of fossils. And really what they've seen, there's no dinosaurs here, that would have been longer than 5 to 25 million years ago, or the last 50,000 years really, I guess, when this was surfacing. But it would have been something, it would have been species that are more recent than things like that. So we're seeing a lot of these things called dire wolves and these saber-toothed cats, which I'll show you an image of here in a minute. But the other thing that we find a lot of here is natural gas because of the decomposition. So remember, methane happens as a result of decomposition. So because there's so many living things that are trapped in there and decomposing, there is a large amount of natural gas that also escapes. So if you go to the tar pits, you have this very rotten egg type smell. That is from the methane gas. Okay, so these are the two types of species that you'll see. This is they've dug up a lot. They have those big mammoths. You've probably seen the images of a woolly mammoth before. So they have dug a few of those out. These are the two most common things that they find. These are dire wolves and saber-toothed cats. So dire wolves, this is the common wolf. This is if you go see a wolf in nature today. It's really hard to tell because if you haven't actually seen a gray wolf, they're actually really pretty big, modern day gray wolves. But the dire wolf is massive. And I know it's hard to tell if you've never seen a wolf, but this is a very big skeleton. And again, if you go visit their museum, you'll be able to see just how massive this is. So it's pretty cool. And then the saber-toothed cats kind of have an interesting look to them. They sort of look like something that we're familiar with, maybe kind of like a cheetah type skin, but maybe like a saber-toothed tiger-y type look to them. But they call these saber-toothed cats, and you'll notice also pretty large, but kind of shorter and stubbier bodies than what we'd expect to see. So a little bit different, but you can kind of see the resemblance to something more similar to today. Okay, so those species are both extinct now, but because they got caught in tar, but also those species that weren't, the portion of the population that wasn't caught in the tar is also still extinct. And really when we see extinctions, it's because we see that those species can't adapt to the changes in that environment. And that's kind of what we saw with those two species. It's actually kind of interesting. A lot of extinct species are much larger than the species we see today. So like we don't have really anything that's the size of a woolly mammoth, right? I mean, elephants are close, but mammoths are way larger than elephants, which is pretty crazy to believe. Or if you think about things like dinosaurs, those fossils for dinosaur skeletons are massive. We don't have anything that big on our planet right now. So it's pretty impressive to think about some of these species. But the average lifespan of a species appears to be about 1 million to 10 million years. So pretty big range here. But like I mentioned earlier, 99% of the species that have ever lived on Earth aren't here anymore. So we do see this pretty constant cycling of species dying off as changes to the planet happen. Sometimes, however, we see mass extinctions, and we've talked about mass extinctions. This is when we see a really large portion of the of all of our species go extinct over a really short period of time. And so we've had 5 global mass extinctions to date that we are aware of, and we keep saying that we have a potential 6th mass extinction happening here. So this is kind of what happened during each of these. This is one of the ice ages, right? If you guys have ever seen that movie Ice Age, this is kind of one of the things that they're referring to here. Another reason why we saw one was drastic drops in oxygen levels. Here we see either asteroids or massive volcanic eruptions. With these ones, with the landing of asteroids or volcanic eruptions, what really happened, it wasn't the impact of the asteroid that killed off large amounts of species, actually. It was the asteroid hitting the Earth and creating basically all of this dust in the air that blocked photosynthesis from occurring. So it basically eliminated the producer level of the trophic pyramid, and because there was no producer level, it filtered its way up to the top of the trophic pyramid, and we lost a lot of species that way. And then, of course, we're talking about this sixth mass extinction where we think that humans are the cause, anthropogenic causes, right? Changing an ecosystem or an environment too quickly. Okay, I think this is the last big idea here. So if you have questions, you can let me know. We're also going to review some of this information before your test on Thursday or Friday. Okay, thanks, guys.